everyone. Today we're going to get started on our last packet for the Jump to Math 3 Honors. So some of what we're going to talk about is going to be review for you guys, and some of it is probably going to be new for you. All right, basically, today we're specifically going to be going over factoring, and again, you've already learned how to factor certain things. We're going to review those, and then we're going to build on top of that. All right, so first thing on your sheet, what I want to do is I want to add in a kind of just a summary of how we're going to handle different scenarios when we're trying to factor. Okay, so on that blank sheet, just go ahead, you can copy down the chart here, and as we learn the different methods of factoring, we're going to put them in here and kind of refer back to that so we have a nice concise summary sheet. All right, now the first thing we're going to go over is factoring using a GCF. Okay, so if you notice up top here on our summary sheet, we're going to copy down, and you can turn your page, make it horizontal. The first step is to always look for a greatest common factor. So no matter what you're factoring, you want to check to see if you have a GCF or a greatest common factor. Sometimes you'll have one, sometimes you won't, but it's always the first thing you want to look for. All right, so if we look here at this first problem, like I said, we're going to look for a GCF. Now, what is a GCF? Basically, it's going to be the largest number slash term that you can divide everything in the expression by. All right, so if we have 63 and 27, okay? Now, you might look at that and be like, oh, well, I can divide both of those by 3, which you're 100% correct, right? But greatest common factor means you need to find the greatest thing you can divide both of those by, right? And you can actually divide both of them by 9. All right. And that is going to be the biggest number you can factor out. So we take a 9 out. And whenever you pull out a GCF, you have to divide everything by that GCF. So we end up with 7x, and then 27 divided by 9 is 3. So our answer here would be 9 times 7x plus 3. All right, and we can put this, we'll actually go up here on our little chart so we have an example of taking out a GCF, right? So if we have 63x plus 27, that would give us 7x plus 3. All right. All right, here. So again, we're going to look for a GCF, always the first step. So 8 and 3, there's nothing I can divide 8 and 3 by. Right? 8, you only have, 2 and 4 and 8. 3, you only got 1 and 3. So there's nothing other than 1 that you can divide all those by. Now, everything is always going to be divisible by 1, but pulling that out in terms of taking a GCF out isn't going to do anything for you. So we wouldn't pull a number out of the 8 and the 3. However, if we look at the variables, this guy has 3 x's, this guy has 1 x. We can pull 1 x out. All right? So that's our GCF, and of course we got to divide everything by our GCF here. So we end up with 8x, and then when we divide things with exponents, we subtract. So this has like a power of 1. We do 3 minus 1, and we get 2. So it'd be x times 8x squared plus 3, because these x's cancel. All right. All right, let's try number 3 here. So I've got a 10 and a 5. My GCF here is going to be 5. And then this guy has an x to the 5th, but he doesn't have any x's, so we cannot take an x out. So we're just going to divide by 5, and we get 2 plus x to the 5th. All right, number 4 here. So this one, we don't have any coefficients. We don't have any numbers out in front. However, of course, we're going to look to see if we can pull any variables out. All right. Now, this guy has 2 x's, and this guy has 1 x. You always have to go with the least amount when you're trying to pull out, because whatever you take out, you have to be able to take from both, right? So I know I can take 1 away from each of these. So I'm going to take 1 x out. This guy has 3 y's. This guy has 1 y, so I can take 1 y out. So then I'm going to go ahead and divide each of these by our GCF of xy. All right, so this first guy is going to become x y squared. And then xy divided by xy, anything divided by itself is 1, right? And it is negative, so we get minus 1. All right. Let's try another one here. So this first guy has 5y's. This next guy has 3y's. So I can take 3y's out. Now, the first guy doesn't have any x's to give, so I cannot take an x out of this expression. Any x's out of this expression. So I'm just going to take a y to the third out, and I get y squared plus x squared. And then there's no y's left, so we're done there. All right. Alrighty. So this is an example here of taking out a GCF. Now, like I mentioned, taking out a GCF is the first thing we always look for. All right. So let's go ahead and move on to number 6 here. Now, do we have a GCF here? So this has a 1 out in front, right? So we just have 1, 14, and 40. There's nothing I can take out of all those except from a 1, which really isn't going to help me. And I can't take an x out because this last guy here doesn't have an x. So I cannot take a GCF out here. All right. So now I got to see, okay, well, there's no GCF. Is there something else I can do with this? This guy has 3 terms. Now, generally, when you have 3 terms, you're going to do just typical quadratic trinomial factoring, which you should be familiar with. All right. Now, this first scenario is when a is equal to 1. All right. So let's go ahead on our little chart here, copy this question down. We've got x squared minus 14x plus 40. All right. And when you have a trinomial where this guy, this leading coefficient is equal to 1, all right, that's what I would consider like an easy trinomial factoring. What you have to do is you just have to find the 2 values that multiply to this guy and add to this guy. All right. So if you're struggling on sometimes you'll just like look at it and know the numbers. However, obviously, if you're struggling, you could easily just go write out all of the factors of this last guy here. So if we've got the number 40, we need to find the 2 numbers that multiply to a positive 40 and add to a negative 14. Well, first off, if we know we're trying to multiply to a positive and add to a negative, they're both going to be negative. All right. And when you're listing out your factors, you can just start with 1, right? We know that we can do negative 1 and negative 40. Those do multiply to give me a positive 40. However, don't add to a negative 14, right? So I'm going to keep going. We'll just keep going in order. We've got 1. 2 works. We could do negative 2 times negative 20. 3 does not work. If I do 40 divided by 3, that is not going to, I get a decimal, right? So that doesn't work. 4, obviously, I can do. I can do negative 4 times negative 10. 5 works as well, right? We could do negative 5 times negative 8. 6 does not work. 7 doesn't work, and then 8 works. So once you start repeating, you know you've got them all. Okay, so these are all my options here. And we just got to figure out which 2 of these pairs add to a negative 14. And the 2 numbers that are going to do that here are these 2. So we then set it up like this. You always just put an x and an x, or, you know, if it's an a squared, you would do a and a, whatever. And then you take your 2 numbers. We got a minus 4 and a minus 10. All right. So that would be our answer here. That's all we got to do. So we can go ahead and at least write our answer here. All right. So let's go ahead and try the next one. Number 7. So we've got, we look for a GCF. This guy does not have a GCF. There is nothing I can pull out because I've just got a regular 1 here. So I can't take a number out. This guy doesn't have an x, so I can't take an x out, so no GCF. So what I'm going to do here is just do my multiply add thing, right? Because I've got 3 terms. I'm going to do the trinomial factoring. What 2 numbers multiply to negative 28 and add to negative 3? Or I'm sorry, add to positive 3. So what we can do is just list out different ways to make negative 28, right? And like I said, if you don't need to list these out, that's perfectly fine. I'm just doing that to kind of help those of you who are struggling with it. If you can look at this and just know the 2 numbers that are going to multiply to negative 28, add to positive 3, by all means, go for it. All right. All right. So for negative 28, we are going to do, let's see, we can do 1 and 28. Now, the thing is, we need to multiply to a negative and add to a positive. So we know we're going to have a positive and a negative number here, right? So we can do negative 1 and positive 28, or we can do positive 1, and negative 28. Then we can do 2, right? We get 2 times, negative 2 times 14, and positive 2 times negative 14. 3 does not work. If I do 28 divided by 3, that does not work. 28 divided by 4 works. I get a negative 4 and 7, or a positive 4 and a negative 7. 5 doesn't work. 6 doesn't work, and then 7 does work, and we end up repeating, right? So these are all of our options here. What two numbers multiply to a negative 28 and add to a positive 3? That's going to be these guys here, right? So we're going to write this as x minus 4 times x plus 7. And that would be our answer there. All right, next guy, number 8 here. So again, we are just figuring out what two numbers multiply to this and add to this. Now, like I said, if you can look at this and figure it out without listing the numbers out, by all means do that, right? Like this one, I would say is probably one you should be able to just do in your head, right? 6 and 4 are going to multiply to 24, add to 10, right? So we're going to do x plus 4, x plus 10. All right. Kind of moving forward, I'll probably do most of them like this, where I just look at it and do the problem. However, if you are struggling, please use this method where you list out the factors. All right. But definitely, you know, moving to honors, this is definitely something you want to make sure, like I would get to this point here where you don't have to list the factors out. But I do want you guys to know how to problem solve and get to the answer if you are struggling. All right. Next one, number 9 here. Now, this one is different because we can see that there is, it's not a 1 there, okay? Now, if you remember, the first thing you always have to do is look for a GCF, all right? Now, here, our GCF is actually going to be a negative 2, all right? I can divide negative 2, 22, and 60 by negative 2. So I'm going to go ahead and pull that out, and I get x. So remember, when you pull out a GCF, you have to divide everything by it. So I get x squared plus 11x plus 30. All right. Now, prior to I guess in the beginning of this video, when we did a GCF problem, we would just take a GCF and there was nothing else we could do with what was left. However, with this guy, we take out our GCF and we actually can factor this further. This is a trinomial, and we can see, okay, well, can we find two numbers that multiply to 30 and add to 11? We can. That is going to be 5 and 6. Sorry, that took me a second there. So we still have to leave this negative 2 on the outside. Don't forget about him, all right? If you forget about that negative 2 that you pulled out in the beginning, you're going to get the problem wrong. You have to make sure you put that in there. So you're going to get x plus 6 and x plus, oh my gosh. I don't know why I keep struggling with 6 times 5 is 30 apparently. All right, so we get that. All right. Let's try the next one here. I look, okay, I've got that leading coefficient. I'm going to attempt to take out a GCF here. I got 3, 21, and 90. I'm going to take out a negative 3. Now, you might be asking why I'm taking negatives out and how I know when to take a positive out. A general good rule of thumb is if this first term is negative, you're going to pull a negative out. That kind of just like generally will help you out. However, sometimes when you get into like difference of squares, that rule goes out the window, but generally that's going to be a good kind of method to use is if that leading term is negative, pull a negative out. All right, so we can go ahead and pull a negative 3 out here. All right, and we end up with x squared plus 7x plus 30. All right, and we have to go ahead and see if we could figure out. I messed up a sign here. Hopefully you noticed that. I don't know why. Sometimes my brain just goes out the window. Let's see. What should be negative? The 30 should be negative. Sorry. Right? Because if we do 90 divided by negative 3, that gives us a negative 30. All right. That makes more sense because I'm like, we can't factor this. All right. So then we go ahead. We took out our GCF. Can we factor this further? Yes, we can. What two numbers multiply to negative 30 and add to 7? That's going to be positive 10 and negative 3. So we're going to go ahead and do negative 3 out in front, x plus 10 x minus 3. One thing to keep in mind, I probably should have mentioned this a little earlier, but when you're factoring, like the order of the factors don't really matter because of the commutative property of multiplication. So you could write this as like x minus 3 and x plus 10. You get the exact, that means the exact same thing. All right. Alrighty. Let's go ahead. We're going to skip ahead a little bit. Let's go take a look at number 13. All right. So we go ahead and look for a GCF. Do we have a GCF here? And in fact, we do. In this case, we can pull out an x squared, right? So we end up with x squared minus 16x plus 15. So then we're left with a trinomial here. We check to see, can we factor this further? Well, what two numbers multiply to 15 and add to negative 16? That is going to be a minus 15 and a minus 1, right? Negative 15 times negative 1 gives me positive 15, adds to negative 16. Now again, do not forget this guy out in front here. All right. And number 14. Again, no matter what we're factoring, first thing we look for is a greatest common factor. So here, my GCF is actually going to be a 2x. So I divide everything by 2x. I get x squared plus 3x minus 18. All right, so now I got to figure out what two numbers multiply to negative 18, add to 3. Don't forget your 2x on the outside there. And I'm going to get what? X, this is going to be 6 and 3, right? So we're going to do x plus 6 and x minus 3. All righty. Okay, so now let's go ahead and take a look here at number 14. Now, this one is different, right? This one only has two terms. So, like I said before, the first thing we always look for is a greatest common factor. Can we pull anything out of 25 and 9? We cannot, all right? So, the next thing we have at our disposal here when we have two terms is one method of factoring two terms, if it works out for you, is a difference of squares, okay? So this is how you factor a difference of squares. It's when you have two things that you can square root and they are separated by a subtraction sign, okay? So let's go ahead. We'll copy down the problem that we're working on here. And that is, let's see, 25 minus 9x squared. All right, so what you want to do is square root each of these terms, right? Because if this is a squared, that means if a squared is equal to 25, well, to solve that, I square root both sides, right? I get a is equal to 5, okay? And then when I square root 9x squared, square root of 9, let me square root that. The square root of 9 is 3, and the square root of x squared is just x. All right. Whenever you're squaring something with a power, you just divide it by 2, right? So 2 divided by 2 is 1. You're just left with 1x there. So now we know what a is and we know what b is. You're just going to follow this factoring pattern here where you do a plus b, a minus b. So we're going to do 5 plus 3x and 5 minus 3x. Now, the order does matter here in terms of, like, since the 25 came first, the square root of that has to come first. Since the 9, it's minus 9x squared, that has to come second. All right. So that would be our answer here. This is known as a difference of squares. All right. And we use that when we have two terms that are being subtracted from each other, and we can take the square root of both of them. So we can go ahead, write our answer here. All right. So here. Next one, we, of course, look for a greatest common factor. Is there anything I can pull out here? No, there is not. So I've got two terms. I look and say, okay, well, can I take the square root of both of these? Yeah, I can, right? The square root of this first guy is going to be 5x, and the square root of this second guy is just 2. So if we're following that factoring pattern that we wrote above, where it's a plus b, a minus b, we are going to get 5x plus 2 and 5x minus 2. All right. So let's go ahead and take a look here at number 17. Okay. So for number 17, we, of course, look for a GCF. Can we pull anything out here? And we cannot. All right. So we've got two terms. I've got a subtraction sign. Then I check to see, well, can I square root both of these? I can, right? So square root of this guy, remember when you square root something with powers, you just divide the powers by 2. So the square root of that first guy is going to be x, y to the third, because you do 6 divided by 2. Square root of 36 is 6. So we do xy cubed plus 6 and xy cubed minus 6. Alrighty. Okay, so we're going to go ahead, just for the sake of time, I'm going to skip, like, problems here and there. I do like having all this practice here available for you, and, you know, I'll post the key to this, but just for the sake of time in this video, I'm going to skip some problems occasionally. All right, so we look here at number 19. Now, if you recall, first thing we always look for is a GCF. Do we have a GCF here? We do. All right, we can take a 3 out of everything. So we take a 3 out of the 27, and we get 9x to the 6th. And we take a 3 out of the 48, and we get a 16. Okay? So, you know, this might be the end of the road here if we couldn't factor anymore. However, this is a difference of squares. And it is important that you can identify a difference of squares, okay? So, like, if we go back to this one here, okay? This one was a GCF one with 2 terms, right? We pulled a 9 out. However, first off, it's not a minus sign, and you cannot square root 7x, and you cannot square root 3 nicely, right? So that's not going to be a difference of squares. So keep that in mind, that you kind of have to be responsible for learning to look for that. You may not be blatantly told, hey, this is a difference of squares problem. You have to just look at it and be like, can I do this? Yeah, I can, and go from there. All right. So we can go ahead, square root both of these, and we get 3x to the third and 4. So we're going to do 3x to the third plus 4 and 3x to the third minus 4. Alrighty. Let's try number 22. So, of course, first step of factoring is always taking out a GCF if there is one. So we look here, I can take out a 5 and an x squared. That's our GCF. So I now get 4, not just 4x there, and x to the 10th. All right. Remember, when you divide things with powers, you subtract. All right. So now we're going to go ahead, square root both of these. We get 2 plus x to the 5th times 2 minus x to the 5th. Alrighty. Okay, let's go ahead and try this next one here. So we can go ahead, there's no GCF, so we're going to go ahead and just take the square root of both sides here, or not square root of both sides, but square root of both terms, and we get 9. And remember, when you're square rooting something with a power, you divide it by 2, we get a 9 and an x to the 4th. So we end up with 9 plus x to the 4th, that looks like a 9, doesn't it? Times 9 minus x to the 4th. Now, a lot of the times we're done at this point. However, sometimes you have a second difference of squares, okay? If I gave you this problem alone, right, hopefully you'd look at that and be like, oh, I can square root 9, I can square root the x to the 4th, and it's got a subtraction sign, right? So we can actually factor that further. Now this guy, you cannot, because he's not a difference of squares. It's a sum of squares, but there's no factoring pattern for that. So can't do anything with him. He's going to stay the same. However, we're going to factor this bad boy further. So we get 3 plus x squared, 3 minus x squared. All right. So sometimes you have to look and make sure that you can factor that further. Let's take a look at that, another one of those, okay? So here we look, okay, there's no GCF. We can square root both of these, right? We get 1 and x squared. So we end up with 1 plus x squared, 1 minus x squared. Can't do anything with this guy. He's good. Now, we've got another difference of squares here. I can square root 1. I can square root x squared. So I get 1 plus x and 1 minus x. Alrighty. Okay, so this next, well, actually, we'll stop here.